Okay, so our first step is to simply read in the two Excel sheets, the clinical study and the protein levels CSV files. So you can see on my screen here, I have read in the first file, and I've simply done that by downloading the Excel file and then opening it in Excel. And we can either do this from the File Explorer, or you can do it from the Excel tab, File, and then Open. So this is my clinical study file, and then I also have my protein levels file here. And this is what it looks like. So the second step that we need to do is to just examine the data and make it look a bit more appealing and easy for us to visualize. So one of the first things I do is I highlight it all, and I am going to auto fit the row columns height and width. So once I've selected it all, I go into Format, and then I'm going to go Auto Fit Column Width and Auto Fit Row Height. And this just makes it a little bit easier to see. And I can do the same with the protein levels one. So I highlight it all, and then Format, Auto Fit Height, Auto Fit Column Width. Great. So the next step is to examine the data. To do this, we really just want to eyeball it first and make sure nothing jumps out at us, get a good idea of what the data we're working with, and see what types of analysis we might want to do in the future. So in Excel, one of the easiest ways I find to do this is to use the filtering functionality. So I've highlighted the first row where we've got all of our variable names. And then I'm going to go into Sort and Filter and click on the Filter option here. So you can see now we have a drop down, and this just gives me, I can scroll through all my different subjects. So I can see, if I have a quick scroll, the types of subjects that I'm dealing with. Similar for the ages, I can see I've got a minimum age of 7.2, maximum age of 79. Okay, so that might be something I want to dig into further. Sex, we've just got male and female, so that's good. Again, for weight, minimum 22, maximum 128, and there's an NA here, so that's telling me we've got some missing variables I need to watch out for in the future. Similarly for height, it looks like we've got a few patients on the smaller scale and then up here. And then treatment group, we have the control and drug, perfect. We don't have any NA values there, which is good. And response, no and yes. Great, so I think one of the first things I just want to dig a little bit more into some of the ages, because some of those seemed quite small. So I'm going to just choose a random column. This is just for my examining data. It doesn't really matter where I do this. And I'm going to look at the average. So to see that, I'm going to use the average function. So there we've got a few different options here, but I just want the first one. And I want to select column B. Okay, so you can see my average is 61 and a half. And I'm going to also do the same for height and weight. Just going to label this here for clarity. Age average. Height average. Okay. Average for height. Row E. Okay, cool. And my weight, just so I've got some ballpark figures to look at the beginning and maybe reference to later. Okay, great. So we've just eyeballed the data there. That's a quick examination. Nothing else sticks out to me, just to look out for those missing variables I've got as well. So our next step is to clean the data. So before I do anything else, I really quickly just want to take our analysis that we did over here, and I'm going to move it over to a separate area. Just so that we don't lose it. There we go. And now it's not here anymore. I've got my nice clean data set, and it's over my preliminary analysis. It's over in sheet 1. Okay, so now I can clean my data. So one of the first things we want to do is look at column names, variable names, and make sure they're nice and consistent and nothing jumps out at me. So a quick eyeball: subject ID, age, sex, weight, height, treatment group, and response. So immediately I'm seeing I should probably rename this into lowercase just for consistency. We've got treatment group here, which is truncated, but that's absolutely fine. I fully understand what that means. And another thing I see is subject ID. So if we go into our other data set, into our protein levels data set, I can see that we've got participant ID and protein concentration. So previously we had subject ID. So I'm gonna, for personal preference, I'm gonna choose to rename this one to subject ID. And now they match across data sets. Great. So the next thing I need to do is to look out for missing variables. So I can instantly see I've got one right here. So let me use my filter columns just to go and inspect this. I scroll down and I can see the only type of missing variable we have is NA in capitals. So we don't have lower score n, lowercase NA, we don't have N/A. Lots of types of missing variables, but it's nice that we've only got one type here to consider. And then I do a quick search on all of the others as well, just to make sure we don't have any missing variables I need to watch out for in these columns as well, and we're all good. So there are lots of ways you can approach this in Excel, but to remove the missing values, we want to remove the entire row of those. So first of all, I am going to replace NA with a missing cell, and then I get to identify those missing cells and delete the whole row. So my first step is to do a find and select, and then I'm going to replace. So I'm going to find NA and then replace it with nothing. I'm just going to leave that variable blank. And I'm going to click replace all. All done, we've made 11 replacements. Okay, great. So a quick sanity check, where we had NA before, that is now missing. And I go to my filter and now we've got blanks. Great. So in order to delete all of these, I need to highlight them. So I go to in the weight column, I go to find and select, go to special, and then I'm going to highlight blanks. Okay, and it's highlighted these blanks for me. And now I simply can go to delete cells, and delete entire row. Great, so that has removed all of those missing variables for me, and it has deleted the entire row. If we didn't delete the entire row, we'd shift things and all of our data would get misaligned. So I can really quickly double check that that has not happened. I'm going to scroll to the bottom of my data set, and you can see we are still perfectly aligned, so that's all good. So the next step in cleaning our data is going to be removing duplicate rows and then also filtering out some irrelevant data that we have. So to remove duplicate rows, I go over to the Data tab and then remove duplicate rows. So first I'm just going to highlight my data and then click remove duplicate rows. So my data does have headers. I'm going to unselect all, and then I'm going to make sure that I remove the duplicate rows based on the subject ID. So you can see in this very first example, subject 001 is a complete duplicate. So if we duplicate on subject ID, that will give us distinct subjects, so it's only one row per subject ID. We click OK. So 11 duplicate values were found. Great. And I will go and do the same thing to the protein levels dataset. I missed this step before, but I also made sure to remove my missing variables from the protein concentration as well. So the data tab, remove duplicates. And again, I'm going to do this just on subject ID. Great. So now if you remember back when we were analysing our data for the very first time and we were eyeballing it, we saw that there were some miscellaneous ages. So we've got these really young people that are in our data set, and we don't want them here. We don't want any paediatric patients in our data set. This is simply for adults. So we are going to remove these guys. So to do this, I've clicked on the filter. I'm going to go to number filters, and then I'm going to say we only want to keep greater than 21. So show rows where the age is greater than 21. Greater than 21, okay. Okay, and if I click on it now, oh, so it's only showing them. So our next task is to create new variables. The first thing we want to do is to create BMI and add it in as a new column. So to do this, we simply go to the next column. I'm going to put a title in there of BMI, and then I'm going to write my formula in the next one. So again, we use equals. So BMI is height, so I click on height, divided, oh no it's not, sorry. BMI is weight divided by height squared. And there we go. And now I'm just going to populate the rest of my cells with that same formula. So I'm going to go all the way down to the bottom. Oh my gosh, I'm dragging for ages. Here we go. So we've got all of my BMI down there. And then if I go back to the top, I'm also just going to add a filter on that as well. I have to redo them all. So I've got my filter column here in BMI. I'm just going to scan this quickly and make sure there's no missing. Great, it looks like we've done everything correctly. So the next step of our analysis is going to be merging the data sets. So to prepare for this, I have actually copied and pasted the protein levels workbook from the separate workbook into a sheet within the same workbook, so we can work with both of these in the same area to make it a bit easier. So to merge the two data sets together, there's lots of ways you can do this in Excel, but I am going to do it using a Power Query. So I select my data and I want to convert both of these into tables first before I can merge them. So I go on the Data tab from Table/Range. It asks me to select my data. I've got the correct range here, and I say my table does have headers. So I just wait for it to load now. And I'm going to give it the name and then I close and load this to Excel, and I say create a connection, and that has loaded in here. So now I just repeat that process for the protein levels one. So select my data tab, creating a table, waiting for it to load, and then I can name this protein levels. Great, and close and load it to the workbook, creating connections. Of course, we've got both of these now, and now I want to merge them. So I go to my data tab and I say get data, and I combine my queries through a merge. So my first one is clinical study, and my second table is protein levels. And now I select the column variable that I want to match on, which is going to be study ID. And I select the type of join that I want to do, which is going to be a left outer one. I'll just wait for this to do its thing. Wow, that's quite a number of rows. I wasn't expecting that many. I think we might have some empty columns that it's selected. Sorry, some empty rows at the bottom. We've got 67, 8567 to 8575. Okay, I'm going to click OK for now. And then I can double check what's going on in here in the merge. Scroll down, have a feeling, keep going, keep going. When we get to, we had around 700 before, I think. So I just want to check that we still have that many. Yeah, we do. We've just got loads of nulls that it's filled with. Okay, that doesn't matter. We can cope with that. Okay, so the next step, I've merged my two queries and I want to expand the protein levels one. So I click on this expand, and because we've already got subject ID present, I only want to include protein concentration, and I don't need to use the original name as a prefix. And I click OK. I'm also just going to take this time to rename this study combined. And we've got all of our protein concentrations that match with our users now. Okay, it's taking longer because I left all of those null ones in there, never mind. So I'm going to close and load, and I'm going to load this to actually as a table now and in a new worksheet. So we'll just give this a while to load. Okay, so our table has now combined, has merged. We have merged the clinical study and protein levels sheets into one merged data set. One word of advice that I did just make the mistake of doing is if you have selected all of the null columns, it takes an extraordinary amount of time. So I did pause the video and go back and correct this mistake and just selected my cells which contained data, which sped up the process a big amount. Using the Power Query tool is really powerful, as you can see. We can do lots of different things here, and if you wanted to use this tool at the very beginning to eyeball your data, this is another way to do it. So for example, there's lots of different things you can do when you're actually inside the Power Query itself, or when you're outside here. Just one thing you can do is insert slicers, just to visualize that data. So this just allows me to flip between, especially categoric variables. So say I want to add in a sex, treatment group and response slicer. I can put these in here and they let me flip between the data sets. So now I've clicked on no, all of the responses have filtered, and it's just another way to split that data up. So now I've gone for no response, female, with the control drug, and it lets me look at that data really easily. So just another thing, another tool to use when you're visualizing your data. So our next step is going to be aggregating the data, and this is really getting into the nitty-gritty stuff of being able to analyze our data and being able to look at what's really going on. So when I say aggregate, what I mean by this is grouping the data and comparing it. So we can use one of our queries to go in and be able to group the data. So I'm opening up our Power Query for the combined data set. And what I can do here is use the group by function. So I'm going to go on to advanced. And now, so what do I want to group? I want to group initially to look at our different treatment groups and make sure everything is going on as it should. So if I group the treatment group by treatment group, and I'm going to look at the mean of the age. So I look at the average age. I can also look at the count of subjects ID. So we're going to sum together the subject IDs. Apologies, that's not sum. We want to count the rows, otherwise we'll end up with a sum. Yeah, so we want to count the rows and look at the mean age. We can also look at other things than the age, such as the BMI. So this is helpful to look at just to make sure we've got a representation across the group. Okay, and now let's look at what this looks like. So across the two treatment groups, the drug and the control, you can see that the mean age is roughly the same, count exactly 50-50, and the BMI is roughly the same as well. So this is great, this is a good sign. We want our population distribution to be the same across them both, and we have got that. And I'm just going to save this as a separate table in case you want to look at it later. Okay, so we have aggregated based on treatment group, and we've looked at our population. Now I want to aggregate across the response as well. So I'm just going to go back one step as we start from the beginning again and do my group by again. So that's fine. I'm going to go to advanced. So again, I'm going to group by treatment group still, and then I'm going to add in a separate group for response. We can still add a count in here, that's always helpful. And now I can put my mean age and mean BMI in here as well. Mean age and mean BMI. So now I'm looking at if there's a difference in population in response additionally. Something that's also interesting, I can look at whether the sex varies across the response as well. So I'll actually add a group in here for sex. Okay. Great, so now you can see I have 8 different combinations. I've got my drug, my control, both for female and male, and for responders and non-responders. So there's a little bit to get your head around here. So to make this a bit easier on the eye, I'm just going to use my filter button to visualize these. So let's look at just the drug. And we can see here there's not too much of a difference in the count, but a slight difference between responders and non-responders and responders. The same sort of distribution across male to female, with slightly more males not responding than women. Although that being said, it looks like we've got a slightly different count for the total population here. So we should probably count that as a percentage rather than a solid count. Now I can look at my control as well. I'll include that here as well. Going back to that step, and I'm going to filter this to just being a yes response. Okay, so now we're looking at everyone that responded, both male and female, for the drug and the control. And it looks like there is a clear difference here in the number of people, both male and female, that responded to the drug than the control. You can see here for female we've got 100 responses for the control, whereas, for the female we've got 100 responses for the drug, whereas for the female we've only got 66 responses for the control, and for the male we've got 58 responses for the control and 106 responses for the drug. And you can see both our age and BMI profiles across these two groups is roughly the same. So far we are just looking at numbers in a table, which is quite difficult to do. So really you want to visualize this to really make a proper analysis on it. But before we do that, I would like to also analyze the protein concentration and see whether that has affected our response as well between the different treatment groups. So I'm going to go back to the beginning again and add these in. So I'm going to add my group by. Okay, so now I am just going to group by treatment group and response. I'm going to leave the sex column out of it for now because I think you just want to keep it simple for now, but you obviously can go in and look at that afterwards. I'll keep the count in there. I'll just keep the mean BMI in here just to see this. And I'll add an aggregation. So now I want to look at the mean protein concentration. So I want to do an average across protein concentration. And obviously we can experiment with loads of these different grouping combinations. I'm just doing a few simple ones to show you guys. Okay. So now I have removed sex, it's a bit easier to look at these counts. So we can see that there are some differences between the drug and the control and also for the response. We can see here that we have a higher response for the drug than we do for the control, which as an immediate sign is a very good sign that the GSK drug has worked over the control. So now we can visualize some of the data graphically. So in Excel, I am simply going to highlight some of my columns that I want to visualize and then convert those into graphs. So one of the first things we can look at is whether how age responds with treatment group. So I have highlighted age and highlight treatment group, and then I go to insert and I look at the charts. So one of the things I can do, it comes up with some recommended charts, but some box plots are really helpful for us to see these categoric variables. Okay, so here we've got a summary by treatment group of the sum of age, and sum of age isn't quite correct, so I can go down to values and change this here. Let's put that as the average. So here we go, I'm summarising by the average of the age between the two treatment groups. So you can see the difference here between 61.535 and 61.555 is so small. So overall, like we said on our initial check of the data in the previous step, we've got the same age over the two treatment groups. So now let's add in by weight and height. We've got these as well, and because they're so different, you can't really see any of these. So I'm going to remove these and let's look at these one by one. Sorry, so we can, now I'll just look at weight. So this shows us if we want to compare things, we really need to be conscious of the axes that we're choosing. So now I'm looking at the weight, but we've gone for sum of weight where this is not correct. We want this to be the average. So the average of weight between the control and the drug, there's a slight difference, but nothing too substantial. And now I'll look at height. And again, it's defaulted to sum. Let's go back to average. The average of height between these two. And I do appreciate that my graph is still titled sum of age, because I'm doing this really quickly, just hopping between the two. I haven't paused to properly rename all of these, but obviously you would do that if it was for a static report that you want to give to people. So just eyeballing this, there's nothing to be concerned about here. So now we can go back to looking at age by treatment group like we had before, and I'll put it back to the average again. And now let's include response as well. So we've got how age varies over treatment group. Let's include response. So now I've got control, the control and the drug, and whether we had a negative response or a positive response. So you can see here for age, in the control group, there's not too much of a difference between our populations. However, for the GSK drug, you can see there's quite a difference between people that did respond and did not respond. However, when you look at the numbers, this is a little bit less significant than we first thought. This is between sort of 61 and 62, so only a year, but there is a difference there. Okay, so now I'm going to do this in a separate sheet because I want to keep this for later. So I'm going to go to a separate sheet and I'm going to do what I did again. So sorry, go back to my original data. I'm going to select whether the protein concentration had an impact. Just make sure that I've selected the data and not the missing values. Yep. So let's look at protein concentration and treatment group. Sorry, I just need to select these properly. protein concentration and treatment group. So you can see we do have some missing values for the protein concentration, so I can ignore those later as well. So I think I'm going to do that now actually, because if I'm going to summarise over them. Okay, so now we can look at some more visualizations. So I've done this for BMI and the protein concentration, and I've just done part of this ahead of time. So we look at BMI across the control and drug groups. We can see that on average there is a difference in the average BMI. However, if you look at the number, it is not that significant. So now we can add in the response variable as well. Okay, so was there a difference in the population group that responded between the control drug and the GSK drug? So we can see here that there is a difference. You're looking at the GSK drug, the average BMI between responders and non-responders is roughly the same. However, looking at the control group, the average BMI between responders and non-responders is different. We had a larger BMI as the average for people that would respond here. So it's just a different population group that might be being targeted by the control compared to the GSK drug. So now let's look at protein concentration. So here we have the average protein concentration by control and drug groups. So you can see here there is a small difference, and let's add in the response variable as well. So between the control group and the drug group, between the non-responders and the responders, there is a slight difference. I'm going to swap these around the other way, and this might make it a little bit easier. So for people who did not respond, they had a higher protein concentration, and for people who did respond, they had a lower protein concentration. So I can actually just get rid of this control group here, just so we can look at these, and you can see that there is a difference here.